Here's a 19-inch Sylvania color TV from 1982 that uses the E32 chassis. This TV was actually made after North American Philips, or NAP, acquired the Sylvania and Philco brand names from GTE in mid-1981. I acquired this particular TV from a repair shop who had set it aside a long time ago because it supposedly needs a flyback transformer. Whether that's indeed the case, I don't know, but I suspect it probably is, just from what brief checks I've made so far. This is just your standard low-end 19-inch color TV. You got your off-on volume knob, your AFC switch, or in some cases it's called AFT, your VHF tuner, your UHF tuner, and your little flip-down door where your secondary controls are: brightness, sharpness, color, tint, etc. So let's turn this thing around and see what the inside looks like. Okay, here's the inside of the TV, and as you can see, it uses a single board chassis along with another little printed circuit board on the CRT that contains the video output components. Here's our VHF, UHF tuner, auxiliary control board, speaker, deflection yoke, and our permanent magnet convergence and purity assembly. Here's the flyback transformer that's supposedly bad, and this particular part is responsible for generating the approximately 25,000 volts for the CRT second anode, as well as a few thousand volts for focus voltage for the CRT, as well as other operating voltages for the rest of the chassis here. When I got this set, it was totally dead, and I discovered the B+ fuse was missing, as you can see right here. So instead of slapping another fuse in there just to watch it blow or possibly damage other parts, I'm going to substitute the fuse with a standard 100-watt incandescent light bulb. That way, if there's any shorts in the chassis, the light bulb will serve as a load to help protect other components on the TV chassis from damage. I've worked on a few of these Sylvania sets over the years, and they actually produce a nice picture. And by the way, I did check the picture tube in this set, and it's very strong. Actually, that's the first thing I do when I get an old TV, is I check the picture tube, and if it's good, then I'll proceed. If it's not, then it becomes an organ donor. Okay, let me construct my little crude light bulb tester, and we'll fire this thing up and see what happens. Hopefully it won't literally fire up. And from everything I've read, the flyback transformers in these sets were a very high failure part. Okay, I have my light bulb connected to the television set, and we're plugged into my Variac, and we're starting this out at 60 volts, and I can say there's a pretty safe bet we have a short here. It should not be doing that. If everything's okay, then that light should just barely glow at 120 volts. And we're only running 60 volts here, so pretty safe bet this flyback is toast. And I've already checked the secondary sources coming off the flyback, and I can find nothing shorted, so I think we're in for a new flyback here. Now the fun part's going to be finding one. Okay, here we are with 120 volts applied to the TV. And I'm going to turn this on very briefly. That should not happen. Under normal circumstances, that light bulb should just barely glow, or at best it should come on brightly for a split second and then dim back down. So we definitely have a short here. And since all my ohm meter tests of the horizontal output transistor and the secondary sources off of the flyback reveal no apparent shorts, then I'm going to assume that this flyback is shorted internally. So what I'm going to do is remove the original flyback, and I'm going to test the flyback with this Syncor analyzer here, which has a flyback ringer built into it, and just see how it tests with that. I'm sure it's going to turn up bad. Okay, I have the flyback removed from the television set, and I have it connected to my Syncor video analyzer, which has a built-in flyback and yoke tester feature, and have the controls set to ringing test. Turn on the power, and by the way you do this, you connect one lead from the tester to the B+ input to the flyback, and the other lead to the pin on the flyback that connects to the collector, the horizontal output transistor. And I will rotate this ringing test knob through its positions. And as you can tell, my suspicions are confirmed. We need a flyback transformer for this television set. So if anyone out there has a flyback or knows of where I can get a flyback for one of these old Sylvania E32 chassis TVs, I would appreciate the help. Okay, that's about all we can do for tonight, so thanks for watching, and as soon as I get a flyback transformer that's good, you should be seeing this TV in action. Here's a 19-inch Sylvania color TV from 1982 using the E32 series chassis. You may recall that I made a video of this set a while back where I demonstrated how to use a 100-watt incandescent light bulb to substitute for the B+ fuse for troubleshooting purposes, and I also demonstrated some other testing procedures in order to determine that this TV had a bad flyback transformer. Well, unfortunately, a new flyback transformer has not been available in years, and I didn't have anything in my junk box that would work, so had to put this TV off to the side until a suitable part could be found. Well, that moment came this morning when the UPS truck pulled up in front of my house. A gentleman in Georgia who owns a TV repair shop and who also enjoys collecting and repairing vintage electronics just like I do. He happened to be at the recycling center a week or two ago, and someone had dropped off an old Sylvania TV similar to mine, and he remembered that I needed a flyback for one of these sets, and fortunately they let him take the TV, so he brought the set back to his shop, and someone had ripped the power cord out of it, but he attached another power cord, and it was determined that the TV actually worked. So instead of that set getting crushed and sent to China to aid in the manufacture of some throwaway garbage, it's going to help keep another TV alive. I think he kept the CRT and the knobs and the tuners and maybe a few more parts for possible future use, and he sent me this whole chassis, which should help greatly in getting my set going. So Danny, if you're watching this video, thank you very much for sending this to me. It's greatly appreciated. I could take the easy way out and just swap the whole chassis out, but that's not very satisfying to me. it's a lot more satisfying to repair the old chassis, so that's what we're going to do here. This particular chassis was manufactured in January of 1981, and at that time Sylvania was still owned by GTE. I think it was sometime in mid-81 when they sold out to North American Philips. My TV was made in, I believe, February of '82, so it would have fell into the North American Philips era. This E32 chassis and the E34 chassis that's similar, that was used in console models, was in production for quite a number of years. I think 1980 was the first year, and 84 I think was the last. So without further delay, let's get started on this and see if we can get this TV going. So what we'll do is remove the screws holding the back on this TV. Yeah, I actually put this TV back together when I determined that we couldn't fix it right away, so I must be getting better. My usual routine is to just leave stuff torn apart until I can get to it again. So I will remove all of the screws from the back cover, and then remove the back to gain access to the chassis. Okay, the back cover has been removed, exposing the chassis. And I have one correction to make. I think I said this set was made in February of '82. It was actually made in January of '82. But still, this was made after North American Philips acquired the Sylvania and Philco names from GTE. For a few years, North American Philips continued to use Sylvania GTE design chassis, but by the mid-1980s, I think they had abandoned all of the older GTE designs and went with their own chassis designs. Okay, I had previously unsoldered the old Flyback the last time we had this apart, so all I have to do is unscrew the mounting screws, and then we should be able to extract the old Flyback from the circuit board. And the way we unsolder these is, obviously we need a good soldering iron, and we use a device such as this. Let me get it here. This is called a desoldering pump or solder sucker. Just a little spring-loaded vacuum pump that you put over whatever molten solder that you want to suck up, and then just push the button and it pulls the solder off. Another thing we use is a product called desoldering braid. It's simply just a copper braid that soaks the molten solder up into the braid. And sometimes it's time consuming to get these old Flyback transformers loose because of the amount of solder involved, but okay, hang on a minute. Okay, so here's the old Flyback transformer removed from the television set. I will turn my soldering iron on and let it get good and hot, and then we will unsolder the new Flyback transformer from the donor chassis and install it in here and see what happens. Okay, I'm now ready to remove the Flyback transformer from the donor chassis, and the way I usually like to do this is go around the first time and remove as much solder as I can with the vacuum pump, and then once I've done that, I'll go around with the desoldering braid and remove any remaining solder. I use Chemtronics brand desoldering braid. It's available from most any decent electronics supply house. I don't like the Radio Shack braid. That stuff's not worth bringing home, so just take my word for it and buy the good stuff. Okay, we have everything unsoldered, and We only needed the vacuum pump to do it, so we will loosen these screws and see if the flyback is ready to just fall on off the board. And here's the flyback removed from the circuit board, all ready to be installed in this television. Okay, just to show you how a good flyback test, I have the donor flyback connected to our Syncor analyzer, and we're set to the flyback ringing test. And on the old flyback, we checked very bad, but as you can see, this is a totally different story. And the highest position on the selector switch setting is the reading you go by. So as far as I'm concerned, this flyback is indeed good. Of course, I had no doubt about it being good. The gentleman that gave it to me said it was good, but I just wanted to connect it to my Syncor analyst just to show everybody how a good one tests. Okay, we have our replacement flyback physically bolted to the chassis. All that's left to do now is to resolder each one of these pins here, and then connect the high voltage anode lead to the picture tube. And then there's a lead here. Where are you? Right here that solders on to the focus control. And then here's our focus lead from the CRT socket that goes here. I'll go ahead and plug that up. Okay, the flyback transformer is soldered to the chassis, and we're just about ready to run the smoke test. Now, once again, I'm going to use the standard 100 watt incandescent light bulb in place of the B+ fuse and see what happens. So I will set up that right now. Okay, the flyback is now soldered in place. We have our incandescent light bulb connected in place with the B+ fuse, and our TV is plugged into the Variac, which I already have set at around 100 volts. That's a good starting point. So let's turn it on and see what happens. Okay, we now have audio, and our light bulb is glowing, but not as bright as it was the first time. Look around on the screen and see if our screen's lit up. Okay, our screen is not lit up. Okay, we have our meter connected and we're reading 58 volts with our light bulb in place. So let's do this. Let's pull the light bulb out and put our fuse back in place and see what happens. I'm satisfied that nothing's going to blow up here. The B+ voltage is supposed to be 112 volts. 58 is a little low. But that's to be expected with the light bulb that I have in place. Okay, we've replaced the incandescent bulb with the 2 amp B+ fuse that's supposed to be here, and we have our voltmeter connected. And it would help if I plug the TV in. Sometimes I just don't know about myself, and the B+ is running 112 volts, which is right where it should be, and we have about 119 volts input, and our screen is lighting up nicely. So I tell you what, let's go dig up a converter box and put a signal to this thing and see what it does.
What we've done will be in sunny Mexico.
Okay, here we are connected to the DTV converter.
Oh, wait, that's the end of a different place.
Back in the old days, I could just flip it to channel 11 and picked up something off of the antenna terminals, but not that way anymore. And it doesn't look too bad.
Emma was doing
considering I haven't touched a thing, I need to adjust the vertical size control a tad bit, but the
that means we can
picture's not bad at all on this set.
and try our new chocolate mint holiday shake. There's some rain. Okay, and we have run.
There's sky, looking at light wind, Seattle, Portland, Interstate 5, good shape, Pacific Coast.
That's cool to enjoy the weather.
Des Moines, Grenada.
My education was paid for out of my aunt's small pension. Do I need to say more?
Plus internship and residency. I don't know how anybody does it these days.
There's our picture control.
Insurance exam. What does that entail, exactly?
Our checklist covers 23 points, takes roughly 30 minutes.
Sharpness.
Were there any interruptions with Mrs. Glazer?
She was on her phone much of the time.
Who was she talking to?
Brightness.
Well, you've been absolutely helpful.
Our color control all the way down, all the way up.
So Grenada Medical School? That really got you going, didn't it?
Well, it's not Sterling.
Tint control.
I'm sure it was more about the low admittance qualifications than Auntie's pension.
Right, no kids. He lives alone in
I
Jamaica.
have to say, for a basic color TV from the early 80s, it doesn't look bad at all. In fact, it looks better than a lot of later model 19-inch CRT televisions.
So you and Hildy...
What a good time.
This is the Juniper.
Oh, that...
The output of this converter box is a little grainy. It seems to be that way on every TV I connect it to.
Free crab cakes, I'll be on my...
I'm out and really.
But I'm going to let this thing run and make sure it's fixed and do a few little minor adjustments on it. But as far as I'm concerned, this TV is fixed.
Live UFC event. It's pretty awesome.
A big thank you going out to Danny for locating the parts that I needed to fix this thing.
How are you doing? Doing good. Welcome to the UFC. I met John Jones, man, the light heavyweight champion. It was like surreal. He's my favorite
And
fighter.
thanks for watching, and more to come later.